Welcome, dinosaur enthusiasts. Today, we're journeying back in time to Cretaceous North Africa, a place surprisingly teeming with long-necked giants, the sauropods. For a long time, the prevailing idea was that dinosaur diversity was on the wane globally towards the end of the Cretaceous. But discoveries in North Africa, especially Morocco, are painting a vibrant new picture. It seems biodiversity, particularly among titanosaurs, a group of advanced sauropods, was actually flourishing right before the asteroid hit 66 million years ago. These colossal herbivores weren't alone. They shared their world with a fearsome array of predators like obeliscaurids, the southern cousins of tyrannosaurs, and smaller plant eaters like the duck-billed Ujnabia. The sheer number of predator species found tells us there must have been a rich and healthy population of herbivores to sustain them. Let's talk about some groundbreaking finds. The phosphate mines in Morocco, near Casablanca, have been a gold mine for late Cretaceous fossils. While mostly marine reptiles like plesiosaurs and mosasaurs are found in these marine deposits, the occasional dinosaur, including an unnamed titanosaur, gives us precious glimpses into the land-based life. Finding terrestrial dinosaurs in marine sediments is fascinating. It suggests they lived near coasts or their remains were washed out to sea. Over in Egypt, in the Western Desert, the discovery of Mansurosaurus shahine has been a game-changer. This titanosaur, about the size of a city bus, lived around 70 to 80 million years ago. What's really interesting is that its anatomy shows links to European sauropods from the same time. This challenges the notion that African dinosaurs were totally isolated, hinting at possible land connections or faunal exchanges between Africa and Europe. Even teeth tell a story. Isolated sauropod teeth from Morocco's Kem beds and similar sites in Algeria, dating back about 113 to 94 million years, show different shapes. These suggest various sauropod groups lived there, including titanosauriforms, titanosaurs, and rhybachosaurids. And again, some of these North African tooth types are similar to those found in southern Europe, further backing the idea of connections across the ancient Tethys Sea. If we look even earlier, to the Lower Cretaceous, about 135 million years ago, fossils from Niger reveal broad-toothed sauropods that were less specialized than their later relatives. But then, in younger deposits from the same area, around 110 million years ago, we find small-bodied rhybachosaurid diplodocoids with highly modified skulls. This beautifully illustrates how sauropod lineages were evolving and changing over time in Africa. These discoveries also help us understand the bigger picture of continental drift. The story of North African sauropods is closely tied to the breakup of the supercontinent Gondwana. Some African titanosaurs, like Shingopana songwensis from Tanzania, which lived between 70 and 100 million years ago, actually show closer ties to South American titanosaurs than to other African sauropods further north. This suggests that southern Africa's dinosaur fauna might have had stronger links to South America during the Cretaceous. And as we've seen with Mansurosaurus and the tooth evidence, there were clearly connections between North Africa and southern Europe during the late Cretaceous. Whether these were via temporary land bridges or even some dinosaurs swimming across marine barriers, these exchanges contributed significantly to the diversity we're uncovering. Compared to North America or Asia, the late Cretaceous dinosaur fauna of North Africa is still less understood. But every new fossil adds a vital piece to the puzzle. Researchers believe we've only scratched the surface of the true dinosaur diversity that once roamed this region. The picture emerging is one of a dynamic and diverse sauropod world in Cretaceous North Africa, thriving right up until the end of the dinosaur era. Their evolution was shaped by shifting continents and local environments, resulting in unique adaptations and a complex web of life. There's so much more to learn, and future research promises to reveal even more about these magnificent long-necked giants. Thanks for tuning in.